Hi everyone, we will be presenting AdPersona. The current system excels at finding the right products for the customers but fails to present them. And in this case, a sustainability architect and a performance gamer are looking at this same chair but with completely different reasons. The architect wished to see about eco-friendly materials and the gamers wish to look at the ergonomics. But both of them only see a generic ad. And our goal is to dynamically rewrite the ad copy so it follows users' psychological profile. So the architects will get to see about recyclable materials and the gamers will get to see about the 12-hour spinal sport. For our data input, we focus on high involvement products where detailed specs matter, like this Millie's classic vacuum. It got rich metadata and they have detailed features that can fulfill varied needs. We created this user personas dataset with synthetic data generated covering all binary combinations of the big 5 personality traits and real-world surveys with some other special corner cases. Example is Mark. He got high in neuroticism, he worries about everything, and he avoids revolutionary products. Our data outputs have 2 structured evaluation objects for both single prompt baseline and our system. We generate the personalized ad, their granular scores, detailed rationales, refinements, suggestions, and overall comments. In data labeling, we benchmarked behavior analysis by feature mapping for personas. We also benchmarked evaluation by labeling the sample of ads so we can ensure high correlation between automated evaluation and human perception.
So let's take a deep dive into the system architecture. We start from the raw input, where it contains the product information and the user bio. Those raw text will be sent to both the baseline single prompt ad generator and our multi-agent system. In the MAS pipeline, the agent 1 will turn the messy raw text into a structured JSON profile and send it to the agent 2. Let's take a look at what the agent 2 is. So it's just the reasoning engine for our system, utilizing the chain of thought prompts. Its core function was to synthesize the core need. And also it will select exactly 1 to 3 traits from the products that genuinely matter to the user. It also forces negative constraints. Say if the user does not like a specific thing, it will be filtered out and the agent 2 will ensure that it never reaches the ad generator. So we run both baseline model and the MAS system parallel. We send the both generated ads to the agent 4, the evaluator. If the pipeline result was not clearly better than the baseline, the agent 4 will generate the refinement suggestion and send the suggestion back to the ad generator. This action will take in the maximum number of 3 times, after which we will take the best result. So, and let's zoom into the ad generator. So this is the creative layer. Instead of simply rewriting the product manual, it only receives the selected traits from the agent 2. And the core function was to weave the specific traits into a concise narrative that matches the persona's communication style. So in order to measure the success, we introduced the ad quality score, where the personalization and core need was much heavily weighted over the sentence clarity and fluency. So a baseline ad would be grammatically perfect, yet still score very low if it does not align with our core need. So in order to success, the MAS result has to be at least 15% better than the baseline. Across the 38 results, we can see the total AQS score was brought up from 5.88 to 8.23, where the biggest jump was coming from the personalization depth, where the score was nearly doubled. Linguistically, we can see there's not much difference between the two systems as the powerful LLMs today can really just consistently generate the coherent sentences. So that's also the reason why we lower the weights in our equation. So from the charts, we can say that the baseline model was simply generating the generic ad, whereas our model was actually focusing on the target user psychology.
For qualitative results, let's revisit Mark. Baseline output failed because it's too generic and it ignores Mark's anxiety. Our system was much better because it mentioned about minimal risk and highlighted the 7-year warranty, and which led the score to raise from 4.8 to 8. But the system isn't always perfect. In this game, Alex, the gamer, is looking explicitly at the neon chair, and the chair happens to become a near gaming chair. When the keywords matrix perfectly, the reasoning agent becomes redundant. Our first key learning is that the structure beats prompting. Separating strategist from writer beats giant prompts. We also found out that GPT-5 raises the performance of the baseline, which gives a narrow gap for simple cases. Our evaluator agent is much more stricter than humans, actually, and in the future, we propose to use a router to send simple ones to the single prompt baseline and complex ones to our system.